this video, we're going to focus on hash table data structure. So what is a hash table data structure? A hash table, it is also known as a hashmap. It is a data structure that allows efficient retrieval, insertion, and deletion of key value pair. What is a key value pair? I've provided examples of key value pair in this video. For example, the first key value pair we have, our key is 10 and our value is 100. The main characteristic of a hashmap is that it uses hash function. Hashmap use a hashing function to map keys to indices in an underlying array, enabling constant time average case operations. In this example, I've provided a simple hashing function. Our hash function has a key parameter, and then it's going to return key modular size, and the key modular size is the index. Key modular size is going to return the index, where the size is the size of the hash map array. Let us see an example of how we are going to implement hash map. The first thing we need to do is to create a hash map array. So in this case, we are going to create a hash map array of size 10. Let's create. After creating the hash map array, like we have created this hash map array, we need to have our key value pairs. I've provided a key value pair that we are going to insert in our hash table. So before we insert anything in the hash table, we have to calculate the index using the hash function. So in this case, we are going to use the hash function provided above here. We can see that our hash is going to accept a key, and then it's going to return the index, where the index will be the key modular of the size. The modular returns the remainder. When we divide key divided by the size, whatever is the remainder is the one that we are going to use as the index. Let us now calculate the index of our key value pairs. So in our first example, we can see our key is 10, and we know our size from this hash map array is 10. So let us calculate our index. So this key value pair is going to be saved on which index? We calculate the index. How do we calculate the index? It is key modular size. So 10 modular 10 is 0. The remainder, when we divide 10 by 10, the remainder is 0. So our index is 0. So the first key value pair of 10 and 100 is going to be saved on index 0 here. On index 0. We calculate the next one. We have 25. 25 modular 10 is 5. So this key modular pair is going to be saved on index 5. We calculate the third one. We have the 33 modular 10. The remainder is 3. So this key value pair is going to be saved on the third index. We calculate the third one. 11 modular 10. The remainder is 1. So this key value pair is going to be saved on the first index. And lastly, we calculate the key value pair of 22 modular 10. The remainder is 2. We save it on the second index. The second index of our hash table. The example of key value pair provided is a perfect example. So what will happen? It's going to be saved. What will happen if you have this key value pair of 30 and 300? Let us calculate its index. So we will have that 30 modular 10. The remainder will be 0. So this key modular pair has the same index as the key value pair of 10, 100. So what happens? What will happen? When two key value pair have the same number, the existing key value pair will be replaced with a new key value pair. This is because of collision. When two key value pair have the same index, it is called collision. How do we solve this collision? To solve this collision, we are going to create a linked list. And our linked list will have a pointer that pointing to the next. So our first value will be 10, 10 and 100. Then if two value pair have the same index, a pointer will be created to a, we're going to create a pointer that points, we're going to create a pointer where the new key value pair is going to be appended. Our key value pair is going to be appended to the existing number. It is not going now to replace the existing number. It's going to append. So there are several methods of solving collision. So the most common used method is called separate chaining. We are going to use this method when implementing our hash table. So separate chaining, when inserting a key value pair with a collision, we append it to the linked list in the bucket, like we have seen in the example above. So our 3300 key pair was appended on the 10, 100 key value pair. The other method that you can use is open addressing, where we have the linear probing. If a collision occurs, we check the next slot in the array until an empty slot is found. So we are in the open addressing linear probing. We should have checked for an empty slot, and our next empty slot will be the fourth index. So our 300 key value pair could have been saved on the fourth index. So let us check some of the key common operations that hashmap does. So the first operation that it does is insertion. In the insertion, we hash the key to obtain the index. After we have obtained the index, we handle collision based on the chosen collision resolution technique that we have chosen. After that, we add the key value pair to the appropriate bucket. When retrieving, we are also going to hash the key to obtain the index. Then we traverse the linked list or probe the array to find the key and retrieve the associate value. In the deletion, we hash the key to obtain the index. Then we are going to remove the key value pair from the linked list or mark it as deleted in the case of open addressing. Let us see how I implemented the hash table in C. In this example, I first created a structure called key value that is going to hold our key and value. It's also going to have a pointer that pointing to the next. It's also going to have a pointer that points to the next of type key value. As we have seen the example, I also created a second structure called hashmap. This hashmap is going to have a table of size. Our size I've defined it at the top of size 10. It's going to have an array of size 10, and this array is going to have a pointer to key value pair. A pointer is going to contain pointers to key value pairs. So let us create our let us implement our hash map. So I created a hash map function. This hash map, this create hash map is going to return a pointer to hash map. It's going to return a pointer to a hash map. So the first thing it does, it creates a pointer called hash map, a pointer called hash map of type hash map, and then it dynamically allocates memory using malloc. So we say malloc size of structure hash map. Then we check if our memory allocation was successful. If our memory allocation was not successful, we return null. We're going to return null. Then after creating our array called table, we're going to fill the table with null. We're going to fill the table with null, and then we're going to return that hash map. Let us draw it. Let's draw it for a better understanding. We're going to create a hash map. It's simply an array. Then we're going to fill our array with null. So everything here will be null. Null, 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 null. So we have created our first hash map and we are filled with null. The create function, that is what a create hash map function does. Simply does like this. Then we are going to use this our hash function, our hashing function that we are going to use. It's going to accept it's going to be given a key, and then it's going to return the index, and our index is key modular size. So let us check the insertion, what insertion does. The insertion method is going to be given a pointer to the hash map that we have created above. Then we are going to be given the key and the value that we want to save. The key and the value that we want to save. So the first thing that we do is to create the index. So we pass the key that we have given by the user to a hash map, and then our hash map is going to return the index. Then we are going to create a pointer that points to a key value. We are going to dynamically allocate memory using malloc. We are going to dynamically allocate memory using malloc, and we have created our key value pointer called kv. First, check if the memory allocation was successful. If the memory allocation was not successful, we return null. Then we take the key value pointer we have created. Then we are going to dereference the key. Our key, we dereference the key. Then we assign the value of key that we have given by the user. We're also going in our structure kv, we're going to dereference the value and assign it the value that we are given by the user. We're also going to dereference the next and assign null. So we have created our first key value pair. We have our first key value pair. So we check if our hash map that table.index is equals to null. So if it is equals to null, let's check an example that we created. So this is our example. So we first check if our hash, we dereference the table. This is the table in a hash map. Then we check the index. So table.index 0 we check at index 0. We check if, let's say our first example is key value pair at the index. Let us say the index was 0. So we first check if the index, our table index 0, if it is null. So in this case, let us say it is null. So we say that hash map, we check on the table, our index is 0, give it 0, check if it is null. In this example, it is null. So if it is null, we're going to do this. We're going to add hashmap dot table dot. We're going to do hashmap. We dereference the table and then we give it the index. In our example, our index is 0. Then we're going to save our key value. We're going to save our key value. We're going to save our key value pointer. Then we are going to save our key value pointer in that index. At this index, we are going to save our key value here. So in our example, it was 10. So we are going to save our 10 here. Example, it was 10. And this pointer is pointing to null. We have our next and pointing to null. Our next will be here. It will be pointing to null. That is how it should be. What if now we want to save another? Let us now say we have that, as we have seen in our example, we want to save the key value pair of 30 and 300. So what will happen is that the hash map table of index 0, because 30 and 10 have the same index number, it's not going to have null. So this if statement will not be executed. So the this if statement here not going to be body. This if statement body is not going to be executed. The else if statement is going to be executed. So what happens is that we create a temporary variable. We're going to create a temporary variable, a pointer. We're going to create a temporary pointer of type key value, and then we are going to assign it the first value in our hash table. So in this example, we are going to assign it this key value pair. We are going to assign it this key value pair of 10 and 100. Then we are going to check if the next is null or it has another key value pair. For example, it does not have a key value pair, it is pointing to null. So while our temporary number dot next, we check this next. If it is null, so in this case our temporary dot next is null. So we are going to skip this while loop. Then we come to our temporary variable. We check our temporary variable dot next. Then we assign that our 300, then our key value of 300. Going to have 300, 30, 300, and it next will be pointing to null. So that is how I have implemented the insert. That is how I implemented the insert function. Let us now check the get. Let us now check the get function. So our get function is going to have two parameters. Our first parameter is a pointer, is a hash map pointer. A hash map pointer pointing to hash map. Our second parameter is the key. So we are going to search for this key in our hash map. So the first thing that we do is to hash the key, and our hash function is going to return us with the index. Then we are going to use this index to find our key value pair. Let us take an example. Let us say we had another 0, 1, 2, 3 of 3. Let's say we have 33. Another key value that you had saved of 33 and 330, and it's pointing to null. And it is pointing to null. The first thing that we need to do is to create a temporary variable, a temporary pointer of type key value. Then we are going to assign it the first index. So let us say, for example, we are looking for our key is 30. Let's check if we are. Let's say, for example, our key in this case is 30. Our key value is 30. So we are going to hash the key. So hash, when we give it 30, our index will be 0. So we are going to create a temporary pointer of key value type. Then we are going to dereference the key value pair. So we go hashmap, get the table and the index. In this case, our index is 0. When we derive hashmap, we go to the table. This is our table. Then we go to at index 0. So at index 0, we are going to have our first key value pair is 10 and 100. So we are going to assign the key value 10 and 100 pair to our temporary variable pointer. Let us now check the get function. Let's now check the get function. Our get function has two parameters. The first parameter is a hash map pointer, and the second parameter is the key. And the second parameter is the key. So we use the key to get the index of the key value pair. So let's say, for example, we have 10, our key is 10. So we use 10, we hash it, our index will be 0. Our index will be 0. Then we create a temporary pointer. We create a temporary pointer to our key value, and we assign it the hash map. We go to the hash map structure. We dereference the table, and then in the table we give the index. In this example, our index is 0. So let us see an example. So our index is 0. So our temporary variable will be assigned to the point. Our pointer will point to this key, the key value of 10, 100. This is our temporary variable. Then we check, does our pointer our temporary variable will be 10, 100. In this case, let's say our index was 0. We have this 10 key value pair is going to be assigned on the temporary variable TMP. Then we check, does our TMP is not equal to null. We check this is not equal to null. If it is not equal to null, we check its key. We check if this 100, we say that temporary variable dot key, in this case is 100, is it equal to our key? So in this case, let's say yes, our temporary variable was 10, so it is equal to the key. So if our temporary variable is equal to a key, we are going to return the value, which is 100 in this case. Let us take another example. Let us say that our key was 30. Let's say our key was 30. So if our key was 30, we are going to hash 30. We're going to receive the index to be 0. Our index will be the same as this one. It's going to be 0. Our index will be 0. Then we are going to assign our temporary variable. We are going to, in our hash map, we are going to dereference the table, this table, and give it index of 0, or index of 0. Give it in the index of 0. So when we give it the index of 0, the first parameter key value pair we are going to get is this one. We're going to get 10, 100. So 10, 100 is going to be assigned on our temporary variable. Then we check if our temporary variable is pointing to null. Nothing is existing. So in this case, our temporary variable is not null. So we check if our temporary variable is not null. In this case, it is not null. We are going to execute the statement inside the while loop. So we check, is our temporary variable key. Then we dereference this is our temporary variable. We dereference the key, this 10, and we check it is the same with the key provided by the user. In this case, the user provided that. So 10 is not equals to 30. So if 10 is not equal to 30, we are going to move our temporary variable. We're going to change our temporary variable to the next number. So in this case, our temporary variable is changed to the next. And we know that the next value in our case is this key value pair of 30, 300. Then we continue with we are going to continue with the while loop. Then we start afresh at the if statement. If the temporary variable dot, we dereference the key in our temporary this is our current temporary variable. We check the key of this. We compare the key of this key value pair with the key provided by the user. So we dereference the key, temporary variable, we dereference the key. Our key now is 30. Is 30 equals to 30? That is true. We return the temporary, we dereference the value and we return the value of 300. That's how the get function works. Our third and last operation is the delete function operation that we are going to implement. So in the delete operation, we're going to our delete operation function is going to have two parameters. The first parameter is the hashmap pointer to a hashmap, and so we're going to have the key or the value that we want to delete. So the first thing we do is to hash the key. Then we're going to hash the key, and we're going to get the index. Then we're going to use that index to get we create a temporary pointer variable. It points to of key value, of type key value. Then we're going to dereference. Let's say, for example, we want to delete. We can delete this one. Let us say, for example, we want to delete 33, 330. This key value pair of 33, 330. So our key will be 33. Our key is 33. So when we hash 33, we're going to receive 3. So our index is 3. Our index will be 3. Then we create a temporary variable, temporary pointer variable of the key value. Then we are going to dereference the table and give it the index. In this case, it is 3. So when we dereference, we are going to get this key value pair of 33, 3. We're going to get this key value pair of 33, 330. So our pointer is going to point at this key value pair. Then we create another pointer called previous of key value, and we assign it null. We first check if our temporary variable is not equal to null. So in this case, our temporary variable is not equal to null. But if our index was any other, it will be null. So in this case, our temporary variable is not null. So we check if the temporary dot key, we dereference this with the key value. Temporary, we dereference this value. We dereference that value. So when we dereference, we get is 33. We compare it with the value provided by the user. So it's 33 equals to 33. That is true. 33 is equals to 33. Before we delete, then we go to in our if statement. Inside our if statement, we check if our previous number that we created here above is null. If it is null, in our case it is null because our value is in the first place. So if our previous is null, we're going inside the if statement. Then we are going to assign our hash map at this index. Our index is 3. Here at index 3, so we'll have this. We'll go to 2 to assign the next variable, and we know our next is pointing to null. So this key value pair will be removed to null. We're going to our temporary variable dot next. So this is our temporary variable. We go next, and we know that our next value is null. So this value is going to be removed. So this is going to be removed, and our variable will be null. Now we are going to free a dynamically allocated memory. We need to, after the else statement, we free the dynamically allocated memory, and then we return nothing. Then we return because our function returns nothing. It's a void function. Let's take another example. Let us say we want to delete 3. Let us take another example. Let us say we want to delete that. We want to delete 30. So our key is 30. We give it to a hash function. Our index will be 0. We know our index is 0. We are going to assign our pointer, our temporary pointer. We go to a hash map. It's our hash map. We go to our table. This is a table. We give it at index 0. At index 0, the first element that is there, we have a point. We have this 10, 100 key value pair, a pointer to this key value pair. This key value pair is going to be assigned now. A pointer to this key value pair is going to be assigned a temporary variable. We're also going to create another pointer called previous and assign it null. So we check if our temporary variable is equal to null. We check if our temporary variable is not equal to null. In this case, it is not equal to null. And we start executing our while function. We first check if our temporary variable key value is equals to a key provided by the user. So we dereference this. We have this key value pair. Then we check is 10. This value of 10 is 10 equals to the key provided by the user. In this case, the key provided by the user is 30. So if is it 30, we say that this is not true. So we are not going to execute this while loop. So our previous number, our prev variable, we are going to assign it there, and temporary variable. In this case, it is key value pair of 10 and 100. We're going to assign it key value pair of 100. Then we are going. Then after that, we are going to change our temporary variable. Our temporary now variable will point to. It's going to point to. It's going now to point to temporary variable dot next, and we know that this is our temporary variable dot next. Going to point to this key value pair of 300. The temporary variable now points at this. And we start executing again. We check if is our temporary variable key value equal to the key value given the user. In this case, it is equal. We have given the key value is 30, and the user provided us with a value of 30. So this is true. We go inside this if statement. We check the previous number. If we check if the previous variable is equal to null. In this case, our prev variable is not null. We have already assigned it this key value pair 10 100. So this if statement is not going to be executed. We go to the else statement. So we go to our else statement. So the previous, we assign it the previous, this is 100. We're going to assign it the temporary. Our temporary is this one, temporary dot next, and now our temporary dot next is null. So the previous dot next is pointing at 10 key value. Now its next value is going to point at null. After pointing at null, we are going to free the dynamically allocated memory of this key value pair, and then we are going to return. That is how the deletion operation of a hash map is implemented. Finally, I created a destroy hash map function. This hash map is going to only to free up the dynamically allocated memory. Then a dynamically allocated memory of the hash map. The first thing we need to do, if we check, the size. The first thing we need to do, I create a for loop. This for loop is going to check the size of our it's going to check the size of our hash map. So we have in this case our size was 10. So it's going to check from 0 up to 9. Yes, from 0 up to 9. Then I created a 0 up to 10. We create a temporary variable. We are going to give it every index. So we are going to start from 1, 2, 3, 4, 5, 6 up to 9. So we are going to assign the first bucket as the first bucket of our table as a pointer to our temporary variable. Then we are going to check if our temporary variable is not equal to null. So for example, in our case we have 10. It's not null. It has a 10. It has a key value pair of 10 and 100. So if it is not null, we create another temporary variable and we assign it. We create a temp variable pointer of key value and we assign it to the temporary variable. Then we're going to change our key value. We're going to change our temporary temp to our next. In this case now, we're going to change this temporary variable to point to our next. In this case, going to point to 30 and 300. And we are going to free. We're going to free the first variable, which is this one. Then we are going to check again our variable. And we are going to check our while loop. It's our temporary variable null. Now in this case it is not null. We have 300. It's pointing at 300. Then we're going to get another variable called temp, and we're going to assign this the key value of the key value of 30 and 300. After assigning it this key value of 30 and 300, we're going to change our temp. This temp is going to change it to the next. We know our next is null. Though this TMP is going to point to null in this case, and then we are going to free this 300 memory, and everything will be null. And now our temporary number will be our temporary number will be equal to null. So we are going to exit the while loop. We are going to the second. We are going to increase our I. Our I now will be 1. It is pointing to null. Check if it is pointing to null. In this case it is pointing to null, and that is how I implemented the destroy function. So this is how the let us now execute our function. Let's now execute our function. The first thing we do is we create a hash map. After creating our hash map, we're going to we're going to insert a key value pair, insert 10, 100, 20 and 200, 30 and 300, 11 and 110, 21 and 220. And we are going to retrieve our value. Use the get. Retrieving our value, use the get function. We're going to give it the hash map we created above, and then the value that we want to retrieve, and then we are going to print all the values that you have, retrieved. Let's see how it is working. Let's execute it. Yes, our hash map is working. Thank you guys for watching, and kindly subscribe.